This video was produced in the framework of the Climed-Fruit project and will allow you to discover one operational group involved in the project and the different results and testimonies that resulted from it. Starting, a little tutorial to remind you how to put YouTube subtitles in your language. First, click on the Settings button. And on the Subtitles button. You can click on the auto-generated proposal. Once it is done, click again on the Subtitles button. Now choose your language. Here we are, now you are ready. Let's start with the general presentation of this operational group.
This operational group is located in Friuli Venezia Giulia. In the next slide, you will see where it is. Anyhow, it's the region in Italy with the highest rainfall, and it's a viticultural region. We're quite well known for white wines, but in this situation, you can understand how much relevant mildew and mildew management is in viticulture, and it's quite common in several other wine growing regions. So the copper use in viticulture is quite a topic on debate since many years, especially in organic viticulture, because in conventional farming, copper somehow is anyhow the less harmful product that is used. So I mean, copper is not so relevant in terms of environmental impact, and the restriction in use in copper was only applicable to organic farming till 2 years ago, while nowadays the restrictions are into force also for conventional farming. Anyhow, when we started, we were focusing on organic viticulture and winemaking, and we started from this concern about the use of copper that is quite a problem in terms of residues in soil and in accumulation in the long term. I mean, copper is an heavy metal, and it accumulates in soil, is not degraded, and it has all the impacts on the microbiological function of soil that you can imagine from a bacteriostatic and bactericide molecule. And the accumulation of copper over 100 years and more than 100 years nowadays, because viticulture has been occurring in the same plots since 100 years, is quite a concern. On the other hand, that is already quite a big concern. But on the other hand, we have some concern because climate change is on one side decreasing the rainfall in the region, so potentially also decreasing the need for copper use. But on the other hand, the major conditions are quite different year after year. And there are some moments like this year in May and June with a very high rainfall that is requesting even more use of copper. And the plasmopara, that is the pathogen causing mildew, is changing also its cycle, its biological cycle, that is putting at risk even more the management of its impact on vineyard. And on the other hand, it may request more spraying, more interventions during difficult periods. On the other hand, thinking about the cellar part of this operational group, climate change is also changing the composition of grape, and as a consequence, also the composition of must and wine. And in the case of organic wines, where we want to decrease any inputs, the use of any input, not only SO2, even if SO2 is the most debated one, but the idea is to reduce any use of external input, to have a composition of the grape that is, for example, decreasing acidity or increasing the alcohol content, is posing different difficulties in winemaking. So the idea of the operational group is how to reduce any kind of external input in the vineyard and in the cellar under a changing climate. So not only considering the situation of the years in which the operational group was active, but also looking forward and looking at the evolution of the climate and the condition and the vineyard evolution in the future with this further complication on our heads. This operational group started in 2020, it officially established in 2020, but we started to group the farmers and to work, I mean, in the formation and the selection of the partners since 2 years before. We are in Friuli-Venezia Giulia, as I mentioned in the beginning. It is the northeastern corner of Italy towards the border with Slovenia and Austria. And the objectives I already described them to decrease the use of any kind of input. Working methodology. The initiative was started from the association IAB Friuli-Venezia Giulia, that is the Italian Association for Organic Farming, the regional chapter of Friuli-Venezia Giulia. That is an association gathering not only farmers, but also advisors, researchers, municipalities, and consumers. So it's somehow a multi-actor association. We started, as said, that with 2 years before the starting of the operational groups and before the application for it, and selecting with a very slow, but I mean, that's somehow needed to be slow with participatory approaches. So we dedicated all the needed time we needed to do that. And I have to highlight that in our region at least, but I think all over Italy, it's one of the few operational groups not coordinated by university or research bodies. Why that? Because the bureaucracy behind that and the time to be dedicated to that is quite high. And so very often that's not something that associations, farmer groups, or even big farms are really likely to do. Next slide, please. So as members, we had 5 organic wine growers, different locations and different situations concerning the mildew problem, 2 research bodies, Udine University and Edmund Mack Foundation, 1 innovation broker, that is Vinidea, of course, and the association, IAB Friuli-Venezia Giulia, as a coordinator. In the vineyard, we had, I'm just summarizing then the activity, but anyhow, for 2 seasons, we had in-lab and in-field assessment, measurement of the copper used, the measurement or the attempt to measure, I should say, the rate of active copper. I will get back on this concept of active copper later, and to monitor the effect of rain or even dew on active copper in order to quantify the rate of copper need to have a good protection of the leaves. And as a consequence, this study was finalized to have a tool to decide when another treatment, another input of copper was really needed on the leaves, or if the copper already on the leaves that was originating from the previous treatments is already enough to protect the vine. We have I don't want to bother you with numbers, but anyhow, as the spraying of copper is starting very early in the season and goes on along the season up to July, up to the end of July often, the consequence of the repetition of spraying is an accumulation of copper on the leaves. Nevertheless, not all the copper on the leaves is really active against mildew or any other fungi. And it's not very, very clear so far which are the causes and the form of copper that can be defined as active and which are the forms that are not active towards the fungi. Anyhow, an approximation of definition is that when copper is as a crystal form with a lot of carbon around it, somehow it is blocked there and it's not active. So it's not able any longer to become molecular copper, that is the active one. And it's not, so you can have the copper there on the leaves, but it's not active against the mildew. So that was the point we focused our activity in lab and in field. Then we had some activity in the cellar, monitoring the fermentation process, and try to implement some improved protocols leading to low input, low amount of any kind of input, starting from SO2, but not only SO2. But in the meanwhile, we use also some digital tools to monitor the fermentation. So to be fully aware, so we produce knowledge, able to guide the winemaker in order to, when he has to decide if to do something or if everything is okay, and so he can sleep peacefully and not being bothered to use any other intervention. May I have the next slide, please?
Now that you know more, let's see the results that came out of this project.
The outcomes of this operational group that is already finished since last year. will be presented now by Pier Giorgio Comuzzo from Udine University. This is the part about the cellar work, let's say. And then we have the vineyard work presented by Daniele Prodorutti from Edmund Macron Foundation, and Gianni for the digital, the tool that we are developing to measure the active capper on the leaves.
Great.
Okay, so my task in INTAVIEBIO project was to take care about the winery part of the project, and in particular the focus, as often happens in organic winemaking, was to investigate the aspects related to the production of wines with low or with no sulfite added. We will see it's a hard task, and it's a task which is shared also with conventional winemaking, but in organic winemaking we may have some additional problems due to the fact that we cannot use all the technological tools we have in normal winemaking. However, what is the background? So the starting point of this activity was related to the reason why we need to reduce sulfites in organic winemaking. Sulfites are considered a fundamental additive for their antioxidant, antioxidasic, and antimicrobial activity, but we know that they are also toxic and they have a strong allergenic potential. And this is a risk for the consumers and the operators. Consumers in particular are nowadays aware about the risks of sulfites, so that from the legal point of view, producers are forced to indicate on the label of the bottles that the wine contains sulfites when total SO2 in the wine is above 10 milligrams per liter. So from the technological point of view, the first thing to keep into account is when the producer can act for reducing sulfites. In modern enology, it's quite easy, if the grapes are sound, to significantly reduce or also to eliminate sulfites before alcoholic fermentation, because we can have different strategies and techniques for managing the production of wines without sulfites before alcoholic fermentation. The most critical problem is to reduce sulfites after alcoholic fermentation, during aging, and during the storage of the wine in bottles, so before consumption. Because in this phase, there are less techniques and additives available for replacing SO2, and moreover, we will see these additives are generally less long-lasting than SO2. So how can we act? How the producers can act for reducing SO2 in this step? This was the focus of the project. We tested different additives or bioprotective agents, because we will speak also about bioprotection a little bit, and in replacement of SO2, but also on for replacing what is one of the most traditional systems used in organic winemaking for replacing the antioxidant activity of SO2 during wine storage, which is the presence of, to keep the wine over lees. Lees are composed by fermentation yeasts, which undergo autolysis, and lees are one of the most powerful oxygen scavengers available in wineries. We know that yeast lees have a great capacity of consuming oxygen, and this may protect wine against oxidation. But there is also a side effect of the lees, because lees are very rich in viable microorganisms. In this table, we can see the population of different typologies of microorganisms, of wine microorganisms in fresh lees, so lees collected immediately after the alcoholic fermentation. And we can see that, for instance, total yeasts or Saccharomyces, but also non-Saccharomyces, range from 100,000 cells per milliliter up to 10 million cells per milliliter. Among these microorganisms, we can also see non-negligible amount of viable microorganisms also in lees collected after 6 months of aging. And in particular, some lactic bacteria strains. In this table, Brettanomyces is not indicated, but also Brettanomyces can develop, as we know, in lees during aging. So these microorganisms, which can develop without, if the wine is not protected by SO2, may become a risk of microbial contamination. What is the result of this effect, of this aspect, of this presence of microorganisms in the lees, which can develop in an environment which is free of SO2 or poor of SO2? These unwanted microorganisms can develop, in particular, after when during spring temperatures tend to increase, and they can produce different metabolites. And we know that Brettanomyces can produce olfactory defects in wines. Lactic acid bacteria may produce biogenic amines from amino acid metabolism. These compounds are dangerous because they are allergens, and they can produce some headache or other problems in the consumers. In a work that we have published in 2013, we found, we analyzed more or less 1,000 wines from organic viticulture, and we found very high levels of, generally we found the 40% of these wines was affected by incomplete malolactic fermentation, and in some cases we found very high levels of biogenic amines. So this is the most critical risk, in my opinion, in the production of organic wines, if we want to eliminate completely SO2. The consideration that Oliviero Visentini made during his interview, so to not try to reduce very, very much the content of copper in organic winemaking, and nowadays can be translated also in winery concerning SO2. Of course, in organic winemaking, the legal levels of SO2 are lower than in conventional in Europe. Of course, in organic winemaking, we have to try to reduce as much as possible SO2, but we cannot think in all the conditions to eliminate completely this additive, because these risks are real. So coming back to the INTAVIEBIO project, we tasted different additives for replacing SO2 during the first year of the project. And these additives was tested during for replacing SO2 during wine storage. So we compared SO2 with oak tannins, with different typologies of inactive yeasts, as we can talk about inactive yeasts as low impact antioxidants, glutathione. Lactic acid Bacillus casei is a microorganism which may act as a bioprotective agent just for reducing the risk of microbial contamination in the wines if SO2 is not used. And then we tested these additives alone or by combining some of them, such as lactic acid Bacillus with inactive yeast or oak tannins plus SO2. What about the results? Basically, some of these additives had an activity which was comparable with SO2. In particular, the most performing among them were glutathione, but glutathione was introduced just as a sort of standard, because we know that in this moment, in this period, nowadays in Europe, it's not allowed. The International Organization of Wine and Wine has approved it, but it is not possible to use it legally from the legal point of view now. However, the most performing additives was inactive yeasts and tannins. In particular, tannins demonstrated to be an interesting tool used in combination with SO2. In particular, in this trial, we were able to reduce SO2 from 50 milligrams per liter to 15 by mixing it with oak tannins. And as we can see in this graph, it was possible to preserve catechins from oxidation. Catechins are some of the most oxidizable compounds in white wine. This was a Pinot Gris, and also to reduce the browning and so the oxidation of the wine. In the project, we also tasted a particular analytical technique, which was cyclic voltammetry. And cyclic voltammetry is a powerful technique for studying the oxido-reductive behavior of a given system, in this case, the wine. We can see in particular that the highest part of the curve increases, the height of the curve increases when polyphenols are preserved against oxidation. When we can see in this graph, for instance, that both SO2 and glutathione may act in protecting polyphenols from oxidation. Among the other additives, I introduced in my presentation this slide, which reports that, for instance, inactive yeasts, D1 and D2 are the inactive yeasts, have an effect which was similar to the effect of SO2, even if less efficient, no, in protecting polyphenols. So, what about the aromatic and chemical and sensory composition of the wines produced without SO2? Generally, what we have observed during the project is that the wines produced without SO2 are different with respect to those in which the additive is used. And in general, they are more rich in volatile compounds. So the presence, the absence of SO2 in the winemaking process produces generally wines which are richer in aroma compounds. And this higher concentration of volatile compounds is detectable also from the sensory point of view. We obtained, for instance, in this graph, we have some of the wines which were the control produced without SO2, and some other products, such as those produced with glutathione, with inactive yeasts, and in bioprotection with the lactic acid Bacillus casei, were characterized by a higher complexity, a more complex bouquet, tropical and fruity notes. The presence of tannin tend to be detected by the tasters with notes of oxidized, cooked apple, the spicy. So this is the typical notes of tannins. Sulfited wines tend to be fruity, but they are also characterized by reduction of flavors. And so wines produced without SO2 are different. So just for concluding what the main outputs of this project, different alternatives can be available for replacing SO2, but the problem is that they are not equally efficient in protecting wine against oxidation, and they have a less prolonged action. So the recommendation that Oliviero Visentini made for copper can be translated also for SO2 in winery. Some of these additives may have some sensory impacts. So it can be tannins, for instance, can be detected at tasting. So we cannot exceed in the added dosages. And moreover, if we want to protect these wines against oxidation with tannins or inactive yeasts, they don't give the microbiological protection as it is for SO2. Concerning the microbiological risk, the important aspects are to take care about the hygienic conditions of the winery, to take care about the presence of the lees, and to avoid a too much increase of temperature during spring, summer, because the increase of temperature may trigger microbial contaminations. What is the foreground of the research, of the experiment? Winemaking technology is growing a lot in recent years, and in particular, it is oriented towards the use of biotechnologies and about new technologies based on physical methods, which we have to evaluate, of course, if these new technologies can be suitable for organic production. New additives are being produced, such as chitosan, for instance, which may be interesting from the point of view of both microbial protection and antioxidant protection. And finally, concerning biotechnologies, bioprotection can be a suitable tool for reducing the risk of microbial contamination. So thank you very much for your attention. I'm available for any kind of question, of course, and I hope to
Thanks, Pier Giorgio, was great. And thanks for having compacted it in such a short time. It was not easy at all.
Yes, it's difficult, and I try to not go too much in detail, also for the data. So if you are, if you want some more information, you can also contact me by email. I'm glad to answer any kind of question.
Thanks. Great.
Thank you.
Thank you. Giuliano, shall I go on introducing Daniele?
Yes, please.
Okay. Then this was the seller part. As I said before, it is not really probably the part that of more linked to Climed-Fruit, but I think it was interesting to see that what we do in the vineyard has also reflections in the what happens afterwards. On the other hand, now we go to the vineyard, and we had a presentation from Daniele Prodorutti from Edmund Mark Foundation in San Michele all'Adige in Trento. So it is not in Friuli, but we ask their support due to their knowledge and long-term engagement on this topic. So Daniele, grazie. Thanks a lot. If you want, you can share the screen.
Yes, good morning, everybody. Thanks, Cristina, for the invitation. Okay, now I share the presentation. Can you
yes
see? Okay,
just put it in
yeah,
yeah, perfect, thanks.
Okay, so first of all, I have to thank my colleagues Roberto and Oscar, who carry out the trials, and I have to say that they did a huge work inside this project. First of all, regarding copper, following the EU regulation, today we can use 28 kilograms of copper per hectare in 7 years, so an average of 4 kilograms of copper per hectare per year on average. And so we have to reduce the use of copper in the vineyard. To date, we can say that the reference dose is 200 grams per hectare, with some treatments at higher doses, 300 grams, and rarely 400 grams when there is a high risk of infections of downy mildew. These are the results of trials carried out in the past here in San Michele all'Adige, where we can compare that in experimental training systems, treatment with 200 or 400 grams per hectare of metallic copper can be considered, can bring about from 5 to 10 milligrams of copper per square meters of leaves. So in the trials that we carried out in the laboratory, We take in consideration this kind of quantity. We considered the quantity of copper per square meter of leaf surface. This is always another example of another trial that we carried out in the lab. This is just to say that at higher doses of copper, from 400 and upper doses, the efficacy is the same. So we can consider that the higher dose that we can use against downy mildew is 400 grams per hectare. At lower doses, from 200 and 300, there is a slowly decrease of the efficacy. Even in this case, there wasn't significant differences. In any case, in the field, sometimes we have some problems of efficacy with these doses. The lower dose, 100 grams per hectare, is usually not enough. The efficacy is below the 95%. We can consider 95% as a good efficacy of copper treatments. So, what happened in the field? Sometimes there are some reports that of reduced protection against downy mildew with light rain and using low doses of copper. So the hypothesis that we would test with this project was that leaf wetting, so without leaching, could cause a loss of efficacy of copper. So the aim of this study was to evaluate the efficacy against downy mildew, the Plasmopara viticola, of copper treatment at different doses, and followed by wetting at different timings. Briefly, the material and methods, we from plants, young plants of vines grown in greenhouse. We take little leaves and we did some leaf discs that were put in petri dishes with a humid paper. Then we treat them with the copper at different doses by using the Potter tower. This is an instrument to do the treatment application. It's a very precise way. Then after the treatment with copper, the leaf discs were subjected to wetting at different timings. After wetting, we inoculate the downy mildew, and then after the incubation time, we assess the efficacy on the leaf discs, and in particular, we assess the surface of the leaf disc that were infected by downy mildew. Okay, this is the wetting of leaf disc. Sorry, I can. Okay, this is the different timings of wetting. Okay, we had an untreated control just with treating with copper, and after 24 hours, we carry out the inoculum of Plasmopara. And then we use different wetting hours from 30 minutes to 24 hours of wetting. The numbers. So we use 3 copper salts, Bordeaux mixture, copper oxychloride, and copper hydroxide. The wetting treatments were 6 with the 5 copper doses and 25 leaves discs per treatment. So the total of with this that we assessed were more than 5,000. So a huge job. Briefly, results. Here is the comparison of the efficacy of the free copper salts. We can say that they had a similar efficacy especially Bordeaux mixture and the hydroxide, but the oxychloride showed a lower efficacy against downy mildew at lower doses, 2.5 milligrams of copper per square meter of leaves. But okay, at higher doses, all the free copper cells showed a good efficacy. At low doses, at the same time, all the free copper cells showed a low efficacy. But the most interesting results were resulted from the wetting. In particular, this is what happened with Bordeaux mixture. Okay, here are the wetting hours, and here and compared to the efficacy. Here we can see that at higher doses of copper, with all the leaf wetness showed a good efficacy, almost 100%. But what happened with the interesting, what happened with a low hours of wetting, where we can see that and low copper doses, that there is a significant decrease in efficacy. So our hypothesis, if it's with a short wetting, there is a crystallization of copper, so the copper is no more available. While with long wetting timing, the copper stay effective during the trial. A similar effect resulted from oxychloride. Even in this case, with the low copper doses, there is a decreasing of efficacy with the short wetting time. And at the opposite, we didn't see this effect with the hydroxide. So even the type of copper formulation, the type of copper salt, showed different results. So in conclusion, we can say that under optimal conditions, the 5 milligrams per square meter of leaves of copper, corresponding to 200 grams per hectare, allows an efficacy comparable to higher dosages. But the lower concentrations found in some parts of the foliage that could be found during the growing season show a greater variability in efficacy. Regarding the wetting, the leaf wetting can reduce the efficacy of low copper dosages, and doses, especially doses below the 5 milligrams of copper, are more sensitive to leaf wetting. 1 milligram does not allow an adequate efficacy in any case, and therefore prolonged wetting in absence of leaching does not seem to affect the copper efficacy. For this reason, copper is the oldest fungicide, one of the most studied fungicide, but there are still some aspects on its efficacy that should be studied in depth. And further studies on dynamics of copper crystallization, especially on vegetation, will be necessary. So thanks for your attention.
Thanks a lot, Daniele. Thanks to you, as for Pier Giorgio, for being able to condensate everything in such a short time, because there was such a lot of information. Just to complete the information, while San Michele Adige was doing this lab trial, the farmers here in Friuli were testing different strategies for copper use in their own vineyard with their own methodology. I mean, they chose what to do, and the measurement on their leaves was done. I mean, the amount of copper after each treatment was measured by Udine University. So there was a parallel activity in the field and in the lab to be sure that we are really talking of the same thing. And I don't know if it was, we were really astonished when we saw these results from FEM, because we thought everything was known about copper dynamic. I mean, everybody knows everything about copper, but this was not like that. And so the idea of really knowing more about the dynamic of copper, how it becomes more or less available or unavailable. So for example, with these numbers that Daniele showed us, also a morning dew is enough to deactivate, let's say, copper. So it's something that we never considered. This issue that we saw, that came out from Daniele's presentation, that it would be very useful to know how much active copper is on the leaves. That was the starting point when we said, okay, then now what we do? We have to find a way, easy way to be done in the field, very rapid, because we cannot, I mean, you can do it with the lab analysis. You can pick up some leaves, send them to the lab, and in some days you have the result. But that doesn't work. I mean, if we have to decide if it is the case to make a new intervention of, I mean, to spray more copper on the leaves or not, you need to know it immediately and in the field. You cannot have this some days in between. So we were asking ourselves, can we find out a way, a tool to measure the active, I highlight this idea of active copper, not the overall copper, in the fields somehow. And that's what Gianni developed, I mean, Gianni and colleagues developed in this operational group, trying to have a tool, a viable tool to measure it. Thanks. Sorry, Gianni.
No, absolutely. Can you see my screen?
Yes, yes, yes.
Okay, good. Yeah, thank you for the introduction, Christina. I add something on this introduction because Daniele didn't mention a methodology that they have been applied in Agronomical Foundation since probably many years, which is to wash out, let's say, from the leaves the copper by using a nitric acid solution, and then so you take the leaf, you wash it with nitric acid and then a solution, and then you analyze by ICP the copper which is content in on the leaves. And that's of course is a very effective method to see how much copper, total copper, you have on the leaves, and it has been used for experimental purpose many years. Although it's not something which is very easy to transfer in practice, as Christina was saying, because for different reasons. One is the timing, because you need to wash out the leaf, go to a lab. The lab takes maybe a couple of days to get the result, and then you have back this. The second problem is that in order to have something which is significant, you must measure a certain number of leaves, 10, 20, maybe even more for each lot of vineyard. So it might be quite expensive, not only in terms of time, but also money. The other reason is that it's not so easy to wash out only the lower page of the leaf, where the downy mildew is acting, but usually you just soak it into a solution, so you cover 2 pages at the same time. And the other reason is that you are measuring the total copper, and we will see during the presentation that is not exactly a data that might be sufficient to understand if your vineyard is covered or not. So we said, okay, isn't there any other possibility to have an easy way and an inexpensive way to analyze the copper on leaves? And that's why we started to look for image analysis, thinking that the copper which is on the leaf, if we can somehow take a picture of these crystals or molecules of copper which are on the leaves, that might be easy now with the technology which is available for everyone to take picture, even with very good definition. And the web environment allows us also to make some analysis or some elaboration of this data. So that was the beginning of the history. The idea was trying to estimate the effective copper. I will explain more precisely later what we mean as effective. And to develop an analysis which can be performed directly by the grape growers, even in the vineyard, in case, very low cost and time inexpensive, few minutes. So in order to allow the vigneron, the grape grower, to really have a data that can be useful to decide if or not to get the treatment, exactly for a reason Fanny was mentioning, because the goal is to limit to the spraying only when the risk is really very high. In order to use less copper, save the cost of useless treatment, so reduce treatment, of course, and not to forget the negative effect of compactation of the treatment, because we usually, Manolis was mentioning now, treatments are done in a season where there is a lot of rain. So the soil is wet, and it's very easy when you get into the vineyard with a tractor to increase compactation. That might cause a series of other problems, agronomical problems that you know better than me. So just a little bit of basic knowledge. I have to precise that I'm not a viticulturist, even less a pathologist. So forgive me if I'm not so precise, but the principle is that the downy mildew, so the peronospora, is developing through spores, let's say, that are developing so in the fruit of the spore. When they get on the lower page of the leaf, and when there is some water enough, as we will see, they get into the stone of the leaf, and they grow in the inner part of the leaf, and of course they develop another spore system or spore cluster, if you want to call it, that continue the cycle of infection. But the key point is that the spore cannot get into the leaf from the upper page. They need the stones. And so they are here in the lower page of the leaf, and only when there is water, a layer of water which is available, they can swim, literally swim, to the stone and enter the stone. So what is the copper which is active against this is the copper which is in solution into this water, because if there is copper into this water, the spore is not able to survive, or is not able to even to swim sometimes to the stone. So the key point is that's why downy mildew is progressing as infection when we have rain, because we do have a layer of water, otherwise it's not active. So after I just don't tell you how many failures we had before getting to this point, because as you can imagine, it's not so easy to take a picture of copper on a leaf, which is green, which has a lot of different. So we started at the beginning trying to get the blue of copper solutions in a picture, complete failure. Till when we discovered that there are some things on the market, actually, or at least were in the market, which are indicator paper with a substance inside, which is biquinolin, if you want to, that is coloring in red only when it is reacting with copper and oxidized copper, copper 2. And so that allows us to strange a little bit the paradigm, and instead of going to take picture of the leaf surface, we get an imprint on this paper of the leaf, and we go to measure or analyze or image analysis on the paper, color paper. So that was the principle. So we started to work on this, and what is shown here is the principle of the methodology to get this color paper. So we get from vineyard the leaf. We put the little strip of paper on the lower leaf page, a specific amount of water, 5 drops, or sometimes we can use microliters if you have a precise pipette. We leave in contact the absorption, let's say, for 30 seconds, again, a standardized period, and then we get out this, and after a few minutes, a couple of minutes, a red color is appearing. So this is an example of the different intensity of color that you can get from a sampling. I think I have a video. Yeah, I have a video of the sampling. All these papers are coming from the same vineyard, different places and different site of sampling. And I hope that the video, there is no audio, so just to show you the operation. You see, you get the sample. You may even do it in the vineyard, but of course, if you do that in the house or in the office or in the lab, depending on where you are, that might be more practical. So we position that, take the paper. The commercial name is Cuprotesmo. It's a German company who's producing it. We put the water, distilled water, just to make sure not to have interference. 5 drops in order to have always the same quantity. And then some plastic film to avoid to contaminate the sponge that we are using now to apply a constant pressure during 30 minutes. Meanwhile, of course, you can take the sample and the code of the sample, and you can, while you are counting 30.
It's 30 seconds, not 30 minutes, isn't it?
30 seconds, but
yeah.
They seem very long when you are waiting the video going on. Okay, now 30. You get the paper, and you can see the advanced technology which is used for these operations. But the goal was exactly this: to do something that can be reproduced without any lab or any specific item available. So all this, I don't have here the time on this, but it's less than 3 minutes for one sample. Okay, so quick enough, I would say. Then, okay, we have now. Let's imagine to have obtained this, but is that enough to understand if there is enough copper or not? Of course, we see if there is no copper, like in these cases, or more copper. But the question is, how much is enough to understand? So we decide to use some digital technology, IoT, and all these big words that we are doing, and we developed an app on the smartphone, of course. An app which allows you, of course, when you start, you define which is the vineyard that you are treating, and then the system allows you. It's another movie. Oh, sorry. It's another movie that I can show you. Is set up in a way that you can easily take a picture, send it to the cloud, and get back the result. So that's again is the procedure. You go into the app, of course. You take the picture, just to try to have the right magnitude to get a good picture to be elaborated by the image analysis. So here we took the picture. It's fine. You send it to the cloud. giving, of course, a code and giving all the information that you need to get to understand what it is. The code. And the long code. Okay, send. Of course, before all the series, you take a blank picture in order to allow the algorithm to compare the white or the red, which is on the blank, so no red on the blank. So it's kind of a étalonnage, how to say. So take the base and the base. Again, we have seen that also this operation takes probably 1 minute and something, very quick. And you get, at this point, some results. So what's happening? That in the cloud, there is an algorithm, so a mathematical model, which has been fed thanks to the work done at Mount Foundation from Roberto and Oscar. So using the same system we have seen explained by Daniele with the Potter Tower, they have been prepared a certain number of paper of leaves and then of paper strips, color, with a specific amount of copper which has been sprayed on. So 0 is the white paper, 1, 2.5, 5, 10, 15, 30, and also we had 60 milligrams per square meter. And you can see very clearly that the red color is increasing in intensity. So this amount of pictures, which were at the total 160 pictures, have been used to create the algorithm and to be able to give a number to this red color. So that's the idea. So you take a picture by your smartphone, you send it to the cloud, where the algorithm is giving you back the data expressed in milligrams of copper per square meter. And that's the output of the app. So you get one picture, send it to the cloud, and it gives you back the amount, the estimated amount, of course, in terms of milligrams per square meter of copper. So in this case, is almost 6. In this case, is 3. And also they had the color when it is dangerous is red, when it is normal is moderate, is green, and so on. The overall result of a vineyard, like in this case, all this give you this kind of picture, so you can visually see how much red, how much danger you have, and help you, of course, to take a decision. To be clear, that's not enough to take a decision, but can be very useful when you are in a doubt. I mean, it's not substituting DSS or any other kind of well-established way to decide how to make the treatment, when to make the treatment, but in some cases that may help you to understand if it is better to treat or if you can wait another week or other days or next rain before treating because you are covered enough. So, which are the conclusions? We know now that it's possible to get imprints of the leaf with the color which is proportional to some extent to copper quantity. If we standardize the water quantity, the 5 drops, if you remember, and the contact time, if you remember 30 seconds, maybe it is possible to determine what we call the easy soluble copper, which might be the active, or might be the copper with when you have a layer of water, which is should be able to kill the spore, the copper goes into solution immediately. And if you remember the wetting time Daniele was talking about, that might be very critical if you have something which goes immediately into solution instead of needing hours, for example. Then we have seen that image analysis, what you can obtain with a normal smartphone that every farmer has in his pocket, you can estimate the copper quantity that causes the pink color or red color appearance. It's possible through an app to get the data from this picture. on cloud, and that in operation that is we have seen absolutely possible. Image analysis so might allow the grape grower to quantify directly on the farm the amount of copper which is on his leaves. And the bad part is that nowadays, mathematical model developed is not sufficiently accurate to be proposed in practice. So we need some more data to make it more solid, and some of this work is going on, or actually this operational group has fed another operational group in which we are involved in another region, where we are keeping making measure, like just in these days, and trying to feed the algorithm, also testing some anti-scaling product. So something that might allow to avoid the crystallization, the formation of this carbonate, essentially crystals that may entrap the copper and make it less soluble. So as a conclusion, the operational group on this point was not able to give a practical tool, but I think is a very good advancement toward the possibility to do that in the farm with an easy and inexpensive way. It may be a way to finally have a system that measures the active copper more than the total copper, which is less useful as a data.